Yes.
Is it ready?
Yes.
Okay, press the button to record it.
It's already recording.
Already recording.
Yes. You've been sitting there for
Welcome to math. I'm Mr. Little. This is math. We're talking about algebraic pattern rules today. That's a fancy word that means a pattern rule that changes using more than just like add this, add that. It involves the number term and some fancy things. So here's our kind of formula, okay? It's something times n plus something. What does n mean? When I put an n there, I don't mean the letter n. That letter, using the magic of algebra, stands for something else. What does the n mean? Drew? Variable. It's a variable. It is. It is a variable. And in this case, it means it changes, right? Variable, it varies, it changes. In this case, what does our variable stand for? Tegan? The term. So on our patterning table, we have a term and what that term is worth, called a value. That n means the term. So it'll change for each term in our pattern. For the first term, it's 1. Second term, it's 2. The rest stays the same, but like Drew said, that number varies based on what term it is. We kind of plug that into there, and it changes. Okay, I need some numbers here to make my pattern rule. Who could help me out with some numbers to make my pattern rule? Ariana? Give me a number.
like 21.
Like 21 or 21?
Like 22.
Now 22?
Yes.
Wait, like 22 or 22?
Just 22.
Just 22. Okay. So I'll put it here, right? 22. Okay. And a number to go there. That will make that many groups of for our number, and it'll change. Okay. Owen?
2.
2. Okay. You scared me. I thought you were gonna be like a giant number there. Took a deep breath and I got a little nervous. Okay. So here's our patterning rule. You ready, Caleb? Yeah. Here's our patterning rule, okay? So 2 times n plus 22. So here's our first term. So for our very first term of this pattern, it's 2 times 1 plus 22. Who could help me out? 2 times 1, what's one group of 2? And then plus 22. Who has an idea of the answer? Isaiah? So 2 times 1 is what?
Yeah.
Is yeah.
Yeah.
Yeah, is 2.
Yes.
Plus 22. So 2 plus 22. Brendan? 24. Do we agree?
Yes.
24. Okay. So our first value is 24. We put our term in there. We subbed our term in for the n, and then solved that pattern rule. Okay. Term number 2. So now n is worth 2. So 2 times 2. What's 2 times 2? Just yell it.
2!
Who yelled 2?
4.
2.
I did that as a joke.
Bloopers. 2 times 2 is what?
2.
2. It's 2 groups of 2, which is 4, plus 22. So 22 plus 4. Aubrey?
26.
26. Okay. My third term. So now it's 2 times 3 plus 22. Okay. So 2 times 3, or 2 groups of 3 is what?
6.
6. So 6 plus 28. Sorry. 6 plus 22 is 28.
47.
Okay. So you can begin to see a pattern going this way. We can also know that this pattern, right, is a pattern that goes across the table that way. Okay? So whenever I plug into the n and solve that patterning rule, I can know the term way, way down here if I want to. So I can skip a bunch and I can do 10, the 10th term. And the same thing applies. So now I put 10 where the n was. So help me out. 2 times 10 is
20.
20. Plus 22. So 20 plus 22. Who's got it? 20 plus 22. Mateo?
42.
42. Okay. Or I can go to like something bizarre like the 13th term. Okay. A weird number. All I do is I put that 13 where the n was and solve my patterning rule. So Isaiah, help me out. 2 times 13. So 13 plus 13. Isaiah? So 13 plus 13, yep, so 26. Okay. And then plus 22. Quinn? So 26 plus 22. 6 plus 2 is 8. 2 plus 2 is
48.
4. So 48. Okay? So the really powerful thing with knowing your pattern rule, in like an algebraic pattern like this, in a pattern rule that changes using algebra like that, is I can put any number in there for the term and know what the value is. I can skip way, way ahead, do the 1,042nd term, okay? And use a calculator and solve that term. So it's very powerful. So if you saw something like this on a quiz, right? You need to know that that variable stands for the term, and you can just change that. The rest stays the same. That is a variable, so it can vary, it can change, and you can plug in the term into there and figure out the value of that term for any term in that pattern. Not all patterns work that way, right? We saw here earlier today that those patterns here didn't necessarily follow an algebraic rule like that, okay? But if we know the rule like this, we can plug in the term and find the value of the term really easily, okay? I'm hearing voices, so I should probably stop now. That's math. Thanks for watching. Like, subscribe, and hit the bell.
Please don't.
Yeah.